Caloric restriction, defined as a sustained reduction in calorie intake without malnutrition, is one of the most robust and consistently validated interventions for promoting longevity across a wide range of species. Its effects go far beyond weight loss or metabolic efficiency. At its core, caloric restriction activates powerful cellular defense mechanisms, chief among them autophagy. This process of self-digestion and recycling allows cells to adapt to nutrient scarcity by eliminating damaged organelles and proteins, maintaining energy balance, and preventing the accumulation of toxic cellular waste. In doing so, it provides a critical shield against the diseases of aging, especially cancer. When caloric intake drops, the body initiates a systemic shift in its energy-sensing pathways. Insulin and IGF-1 levels decline, while key regulators like AMPK and sirtuins are activated. These changes suppress the mTOR pathway, a nutrient-sensing kinase that inhibits autophagy during periods of abundance. With mTOR signaling downregulated, autophagy is triggered across many tissues, allowing cells to clean house, preserve resources, and enter a state of increased resilience. This metabolic adaptation helps explain why organisms on calorie-restricted diets show lower rates of age-related disease, improved mitochondrial function, and greater genomic stability. The link between caloric restriction, autophagy, and cancer prevention is particularly compelling. In animal studies, calorie restriction significantly reduces the incidence of spontaneous tumors and delays the onset of cancer, even in genetically predisposed models. One major reason for this is the enhanced autophagic clearance of precancerous cells and damaged DNA. By preventing the buildup of oxidative stress and genomic instability, caloric restriction helps suppress the very conditions under which cancer typically arises. Additionally, cancer cells thrive on excess nutrients and anabolic signaling, states directly countered by the low insulin, low IGF, high autophagy environment induced by caloric restriction. This evidence paints a hopeful picture, yet it also carries important warnings for how these findings translate into humans. While caloric restriction has clear benefits in controlled animal models, long-term adherence in humans is far more complex. The physiological stress of chronic caloric restriction can backfire if it leads to malnutrition, muscle wasting, hormonal imbalance, or psychological strain. Furthermore, the ability to benefit from autophagy-inducing strategies like caloric restriction may decline with age. In elderly individuals, where autophagic function is already impaired, the body may no longer mount an efficient response to nutrient deprivation. In such cases, restricting calories could potentially do more harm than good, accelerating frailty rather than promoting longevity. There is also the question of whether caloric restriction can be safely applied in individuals with underlying cancer or undiagnosed disease. While it may suppress tumor initiation, once cancer is present, energy restriction might support the survival of cancer stem cells or impair immune responses. As with other autophagy-modulating interventions, timing and context are critical. Fasting or caloric restriction could theoretically enhance the effectiveness of chemotherapy or radiation by placing cancer cells under metabolic stress, but without careful monitoring, these same strategies could weaken the host or promote tumor adaptation. Despite these concerns, the overall outlook remains promising, especially with emerging alternatives to strict caloric restriction. Interventions like intermittent fasting, time-restricted feeding, and caloric restriction mimetics such as resveratrol, spermidine, or metformin aim to stimulate autophagy and mimic the metabolic effects of calorie reduction without the long-term burden of food deprivation. These approaches may offer a more practical and sustainable way to harness the anti-aging and anti-cancer benefits of autophagy in real-world settings. Ultimately, caloric restriction stands as a powerful testament to the body's ability to heal and renew under the right stress conditions. By activating autophagy, it helps extend cellular health, delay aging, and protect against cancer. But it is not a universal prescription. Its application requires individualized assessment, especially in older adults or those with complex medical histories. The goal should not be starvation but stimulation, to trigger the body's internal repair programs in a controlled, supportive way. As research continues to refine how we can safely engage autophagy through diet and lifestyle, caloric restriction remains a cornerstone of longevity science, a biologically ancient, evolutionarily conserved tool for survival, now being repurposed for modern health and disease prevention.